All right, so the only thing that we really, couple new things we need to go over is when I have this, and again, I need you guys to interact, so I hope that you unmute and answer. Makes it better for us. If I said x squared minus 4, and I asked you to factor that, what's the first thing you're always supposed to try whenever someone asks you to factor?
Do I make it equal 0?
No, because there's not. So this, if I just give you this is called, I appreciate that. This is called an expression. And when it's an expression, there is no equal sign. So I can't I'm not trying to solve a question right now. I'm teaching a skill, which is called factoring. So what was the first thing on the steps? What did I tell you the first thing you're always supposed to do when you try to factor is?
The signs.
Nope. That is a part of factoring, but that's not the first step. I gave you guys like a little factoring tutorial, and if you're not understanding factoring, I'm telling you guys we need to get better at it, because factoring, for those of you who are not in my class, factoring is a crazy, crazy important skill.
Wouldn't you find, I think it's called GCF?
Perfect, great. You're supposed to look for a greatest common factor. That's what you're supposed to look for. And when we look at this, we're looking for two numbers that go into both these, and there's not one. So there's no GCF, okay? So the first step I'm supposed to do is look for a GCF. If there's not one, I skip it and I go down. What was the second thing you're supposed to look for? Those of you in my class should know this answer. You were supposed to look for special cases. Does anyone remember what the special cases I taught you? There's 3 of them.
If x squared has a coefficient that there's no GCF.
Not necessarily. Are you asking that question? Or stay unmuted,
No.
but are you asking that question or are you making a statement?
Making a statement.
Well, I can have this doesn't have a coefficient. But do they have a greatest common factor? Yeah, so it doesn't have a coefficient, so it can still have that. Anyways, the special cases you're supposed to remember is supposed to be perfect square. If they're perfect squares, difference of squares, and grouping. These were the special cases. And I told you each way you're supposed to know it. There's a way that you tell if something is a perfect square. There's a way you tell if it's a different square, and there's a way you can tell if it's grouping. Grouping has to have 4 terms. Perfect squares only have 3 terms, and difference of squares only have 2. So I look at this and I can recognize this is possibly a special case because it has 2 terms only, and it factors out really easy. It factors into x plus 2 and x minus 2. And that's really important to know for today's lesson because what I'm about to teach you just adds on to that. So the reason we talked about that is because this has different signs. If you are new to my class, I really suggest you go to my YouTube, which is Martin's Math. And under there, I have my first video I ever made on it. It's called Factoring. A equals 1. I would highly suggest you watch that video because every time I try to factor, I'm going to be referring to the way that I taught in this class. So if you don't know my way of factoring, you might get confused. So I would watch this video. Then the next one, I think it's called Special Cases. It's the next video. It's the second video I ever made. And then do not watch the one that's right next to it that says A doesn't equal 1 video. Do not watch that one. Instead, there's one on my channel that says updated. A doesn't equal 1. And it's right in between this year and last year. I think it's the last video I posted on up there, I think. But the updated one, A doesn't equal 1 is the video you want to look for. So these 3 videos are all going to talk about factoring. If you don't know factoring well enough, you need to watch these videos. They're going to be vital to our Algebra 2 class coming from here on out, basically. So if you don't understand difference of squares, what I'm talking about right now, you need to go take a look at this video. And you'll see why, because today I'm going to have you factor this. And the one thing you're going to understand is when we talked about this, this says that they have to be the same signs. And I know that they can't be same signs because in real numbers, if I have same signs, when I go to distribute this out, 2x, 2x, 4, you should know how to do that. This times this, this times this, this times this. It's going to leave me with 3 terms. It leaves me with this guy right here. And I need to get rid of him because this guy has that not there. So this actually is not factorable in the real number system. That's why we had to wait to teach you this until you got to imaginary numbers. This is actually a difference of squares problem with imaginary. And all you do is you take the square root of this one, you take the square root of that one, same thing we did before. We just throw an I in here and then 1 plus 1 minus. So that is how we factor that. That is only factorable in the imaginary number system. It is not factorable from the real numbers. So if I gave you x squared plus 25, what would be in my bubbles? Someone help me out.
X plus 5i and x minus 5i.
Perfect. That's it. It's just basically an extension of difference of squares. The only thing is when I see that plus sign, I put the I. If I had x squared minus 25, my factors would be x plus 5 and x minus 5. Notice there's no I. Why? Because I can factor over the real numbers when it's a subtraction sign. Because a positive and a negative will kick me that negative I need back here. Does that make sense? Anybody have a question? Kelly, what were you going to say?
Oh, no, nothing. I accidentally unmuted.
Okay. All right. Try to factor that real quick on your own. All right, so what tells me that I possibly have a difference of squares problem in this one? What's the key that says, hey, first there's no GCF, so I move on to that. Why, when I look at this one, do I stop and say, hey, this might be a special case? Why?
There's only 2.
Perfect. Who said that, Robert? Perfect. Yes, exactly right. There's only 2 terms. That tells me, hey, this might be a difference of squares. But then I see this plus sign. So I know that if it's going to be a difference of squares, I know it's going to be using the imaginary ones. Do you guys get what I mean by that? Yes or no? Awesome. This is why online teaching is really tough. I can't tell if you guys are understanding this. I can't see your faces. So I really need you to be able to talk. Thank you, Janina. Right here, does this have a square root? Well, going back to old stuff, you should understand if I take the square root of 1/9, what you can actually do is you can actually make this the square root of 1 over the square root of 9. You can actually give the square root to each one of those numbers, and then the square root of 1 is 1, the square root of 9 is 3. So actually, yes, the square root of 1/9 is actually 1/3. Couple things to remember, how I can check to make sure that that's correct, is that means that 1/3 times 1/3 should kick me back to 1/9, right? Because that would be squaring it and multiplying top times top, bottom times bottom. Yes, 1/3 squared is equal to 1/9. So that would mean the square root, and the square root would be 1/3 equals 1/3. All right. Another thing to remember, which I'm actually going to use this fact in a problem coming up, is I've been trying to get you guys to know all year, those of you just joining us, this is one thing I say in math all the time. We don't change numbers, we just change the way they look. So one thing that I do is I took this and I made it look like that. But what I need you to also see is if I have this, I can actually make it look like that if I want to. Sometimes I like this version of it. Sometimes I like this version. Just depends on the problem and what I'm trying to solve. So all of that to say, does 1/9 have a square root? Yes, it does. The square root is 1/3 x. That's the square root of this term. Does this have a square root? Yes, it does. It's 4. Since this is a plus sign, I know it's going to be difference of squares, but over the imaginary number system, meaning I'm going to do 1/3 x plus 4i and 1/3 x minus 4i. Does anyone have any questions on what I just showed you there?
No.
No, I understand it so far.
Now, if I give you a problem like this, someone said earlier, I don't remember who it was, they talked about how we can solve it or something, and I said no, we couldn't because it's not an equation. Do you see how this is an equation because there's that equal sign and equals 0?
Yeah, I see that.
So the difference is now I can do the whole whatever I do to one side I can do to the other, whereas when it's this, it's not an equation, so I can't just do whatever I want to one side because there's no other side to be done to. So I'm limited on what I can do in this one. This one, I have more things I can do. One thing we talk about in my class is we need to recognize how many types of x's there are, and how many types of x's are there in this equation. Equation.
1.
So what does that mean I can do?
Can you square root it?
Not yet. I will be in just a minute. But what does that mean I can do with this x? It means I can isolate the x. And you know what? Since we're in 2020 and this is kind of something we're more used to, we're going to quarantine the x. Okay, x is going to be in quarantine. It's got COVID. So that means we need to get all the other numbers away from it. The reason I can actually quarantine the x is because there's only one type of x, meaning if I have this, and that's what we talked about, some of you didn't have me when we talked about this, you can actually not solve this by doing what I call isolation. You cannot get the x by itself, and the reason you can't get the x by itself is there's two types of x's, and they are not like terms, so you'll never, ever be able to combine them. So I have to solve this by factoring. That's why we talk about factoring so much. So whenever there's multiple types of x's, you have to solve by factoring. Whenever there is one type of x, I don't care if it's an x, I don't care if it's an x squared, I don't care if it's x to the 10th power. If that's the only thing you see, you can get it to where it says x equals, also known as isolation. AKA, we're going to quarantine the x. Does everybody understand what I'm talking about here?
Yep.
I get it.
So it's so important to recognize why I'm doing it and when I'm doing it, because in later, algebra 2, no one's going to be there babysitting you saying, okay, this is why we're doing it this way. You got to start picking that up on your own. And so you know how to attack the problems because they're all going to be mixed up on the test. In chapter 3, we factor like crazy. And we're solving things that have x to the 5th in it. So I recognize that there's just an x squared, so I can isolate it. And when I do isolation, I'm working backwards on order of operations. So that's why I'm going to get rid of addition and subtraction first, and I'm going to do the opposite. So I'm going to minus 25. And I get 4x squared equals negative 25. Boom. Now I'm going to work backwards and get rid of the 4. So I'm going to divide by 4, do the opposite of it. So I end up with x squared equals negative 25 fourths. And now I'm going to get rid of that square root, or square, by square rooting it. And finally, I'm going to talk through this last part. Who put the square root sign in there? Come on.
Sorry, it wasn't letting me unmute. We did.
We did. So what does that mean we have to put there?
Plus or minus.
Perfect. We have to put the plus or minus. I see a square root with a negative underneath it. What am I automatically going to pull out as soon as anytime I see a square root with a negative, what am I automatically going to pull out?
Plus or minus.
No, not because of negative. What?
An I?
Yes, I'm going to pull out the I. That's the imaginary part, because really I'm thinking this as the square root of -1 times the square root of 25 over 4. So because of this fact, that's where the I comes from. And now, what did I say? I just said this just a minute ago. When you have a square root like that, what can you do? Instead of writing it like this, what can I say it again?
Square root each of them.
Yeah, so I can think of it as the square root of 25 over the square root of 4, and hopefully you realize square root of 25 is 5, square root of 4 is 2, so you end up with your final answer being plus or minus 5 over 2i. Now the thing about math, and the thing about like the SATs, is you have to recognize 5 over 2i, plus or minus, can be written as 5i over 2 plus or minus. That's the same thing. And if you think about it, it's because it's like, how do you multiply, right? This is 5/2 times I. And how do you multiply fractions, right? You do 5.5 times I over 1, right? You can write any number as a fraction, just throw it over 1. You've been said that since middle school probably. And then you multiply top times top, 5i over 2 times 1 is 2. These two things are equivalent. They're just different ways of writing it. And you might see it like this on the SATs, or you might see it like this. You need to know both of them. They are the same exact number. So actually, sometimes multiple choice tests can be harder, because if you gave me this answer on a written, I have to say, yes, that's true. Or if someone gave me this. If you look for this and the multiple choice is supposed to be this, and you don't know they're the same, you're going to have a hard time. And some of them aren't so clearly as easy to see. Like when I have 10 plus 5i over 3. That's the same thing as 10 over 3 plus 5i over 3, or even 10 over 3 plus 5/3 I. All of these are equivalent to each other. And like I said, on the SATs, they're going to go back and forth, mix them up, do whatever they want. You got to know the difference between them. Questions on anything I just covered today? That's really basically what I needed to do today.
No, I understand it.
Factoring. I'm not giving you, there will be homework tonight. There's not too much. I am going to start something with you guys too, but I'm going to carry it over and a lot on Monday because I didn't do it in first period. They asked a lot of questions on homework, which I'm totally cool with. So I'm going to start something with you, but we're going to go over a lot more on Monday. What does I equal? This is a fact. This is something we need to know. What does I equal to?
The square root of -1.
Perfect. What does that mean I squared is equal to?
-1.
Because what we did is we really just took the I, and to get from here to here, you squared it, right? So if you take the square root of -1 and you square it, right? The square and the square root cancel out. So that means I squared equals -1. Well, oh crap. Come on. For the next one, I need to talk about an old fact that you're supposed to know. If I gave you x to the second times x to the third, what does that equal? This is something we need to know.
X to the 5th.
How did you get that, Orest?
When you're multiplying x's with different exponents, you add the exponents.
But they have to have the same base, right? You have to have the same base, and then you just add the exponents. Beautiful. Perfect. Now, here's what most math teachers don't do a very good job of, in my opinion. We do not say, hey, if you have this, you can go back to that. And you're like, why would that ever be important? Sometimes it's for concept basics or understanding concepts. How could I rewrite I to the third then?
1.
Nope. Think about what I just showed you here.
I times I squared.
Okay. I Can I do I squared first times I? It's the same thing.
Yeah.
Okay. Now, thinking, because we're going to try to figure out what I to the third it really is. Well, what does I squared really mean? Right? Because this is all I do all day long. I just change the way things look. That's all I'm doing. I changed the way I to the third looked by making it I to the second times I. Same, this right here is the same as this, just change the way it looked. How can we change the way this looks? What does that equal to? It's right above it.
-1.
Yep, -1. I got 3 or 4 people that are really engaging. I hope, Daniel, I hope you start, Taylor, start talking. Come on. What can I exchange I for?
The square root of -1.
Perfect. And then really, what's 1 times the square root of -1? It's really just negative square root of -1. So if someone asks you what I to the third is, it is negative square root -1. I to the fourth. How can I rewrite it?
I squared times I squared.
Perfect. Why did you pick I squared? Could I have done I to the third times I?
It's just simpler.
Why? Yeah, you're 100% right, Kelly. Why is it simpler?
We know what I squared is.
I squared is what?
-1.
Which is much easier than dealing with this one or this guy. So absolutely right. So I'm going to write it as I squared times I squared, which, what is I squared really equal to, Taylor? I'm going to have to start calling you guys out. It's up here on the board. It's not like it's something that's math related. It's legit right here. But sometimes I want to see if you guys are actually here. I have a feeling some of you guys are just logging on and walking away.
You said what's I squared equal to?
Yep, it's right here on the, right here. I even have an arrow.
1.
Nope. Close. There's something in front of the one.
-1.
-1,
Yep.
-1.
So instead of putting an I squared, what can I put in its place?
-1.
Good. Instead of I squared, what can I put in its place?
-1.
Very good. I like that you guys are participating. More of you. Thank you. What is -1 times -1?
+1.
So what is I to the fourth really equivalent to? I to the fourth is just what?
1.
1. So that means these are the 4 you need to know, okay? I is equal to square root of -1. I squared is equal to -1. I cubed is equal to negative cube root of -1. And I to the fourth is equal to 1. Now, why are those the only ones that you ever need to know? Well, let's look at it. Like I said, we're going to go over it more on Monday because I think the more you see this, the better you get at it. What is I to the fifth? Well, if I get to choose which ones I'm going to work with, which ones am I going to work with the most? Like, if I want to rewrite this, what one do you think I want to use the most from over here?
4 and 1.
I to the fourth?
4
Why
and
do I
2.
want to use I to the fourth the most?
Because 1 is really simple.
It's just a 1, right? So how can I rewrite I to the fifth? Daniel, help me out. How can I rewrite I to the fifth? Daniel, you with me still? I heard you earlier. You're unmuted. Where you at, bud? No? Tucker. Tucker. Like I said, I'm doing this because I have a feeling some of you are logging on and walking away.
Yeah.
There we go. Tucker. How can I rewrite I to the fifth? If I can write x to the 6 as x to the 5th times x to the 1st, stuff like that. How can I rewrite I to the 5th, but I want to use I to the 4th as many times as I can? Help me out. Tucker, unmute like you were, please. Jonah? Just remember, I'm recording this, so when I go to like parent conferences or stuff like that, I'm not, make sure that they see what's going on here.
Do you want me to answer it, Mr. Martin?
Sure. That would be great. I'm trying to get some other ones to participate, but I'm trying the best I can. This is tough. Yes, Taylor,
Alright.
go ahead.
So would it be I to the 4th? And then just I?
Perfect. Now, what does I to the 4th kick to?
1.
And what's anything times 1?
Itself.
So really, I to the 5th is the same thing as just I. Do you guys get that? Because this is a 1, and 1 times I is just I. And what is I equivalent to? Square root of -1. So I to the 5th is the same thing as what I was. Let's see if we see a pattern here. What's I to the 6? Nina, what's your question?
It was about I to the 5th. Can you also do I squared times I and
You
get the same
could.
answer?
Yes, you could, but what we were saying is, Nina, I love that you're asking that. We want to use I to the 4th as many times as we can because it's just a 1. Whereas, yes, you could do it, but here it's kind of like more work. What's a -1 times a -1 going to kick to?
1.
Right, so if I just write it as this, it's less work for me.
Okay.
We want to write I to the 4th as many times as we can because it's just a 1, and 1 times anything is just going to be itself. So watch, like I to the 6th is going to be I to the 4th times
I to the 2nd.
Do you get that? So really, I to the 6th is the same thing as I to the 2nd, or
So
-1.
It's just those 4 ones repeating.
These 4 are just going to be repeated over and over and over again, right? Because I to the 14th. Remember, we're going to try to write using I to the 4th as many times as we can. So that's I to the 4th, I to the 4th, I to the 4th, I to the what?
2nd.
Right. So really, what is I to the 14th? It's really the same thing as -1. Can anyone see a faster way of doing this instead of having to rewrite this out completely the whole time, which is what I'm really going to talk about on, you guys are going to be a little bit ahead, but that's okay. What's 14 divided by 4, guys? I didn't hear you.
3.
3.5.
3.5.
Okay, it's 3, right? 4 goes into 14 3 times perfectly, yes? How many I's to the 4th was I able to make?
3.
Do I care about how many I's to the 4th I made?
No.
No. How many are left over when I say 4 goes into 14 3 times with how many left over?
2.
Isn't that what it was equivalent to? I to the 14 was equivalent to the 2 that were left over. So I to the 2nd power. Am I making myself clear when I say that?
Yeah.
So if I asked you what I to the 33rd was equivalent to?
Would it just the square root of -1?
Because it's equal to just what?
I,
And how did you get that?
because 32 divided by 4 is 8, and then there's 1 left over.
Exactly. So 4 goes into 32 8 times. I don't care about that. I just care about that it gets me to 32, which means there's 1 left over. So that's what this is going to be equivalent to. Whatever the remainder is going to be what your I, which we said was equivalent to the square root of -1. So I could even do like I to the 573rd, and I have no idea what that is. All I'm going to do is take my calculator, and I'm going to go 573. I'm going to divide you by 4. And when I do that, I go 573 divided by 4 is 143.25. Do I care about this number right here?
No.
No. What do I care about? What does 0.5 mean there's a remainder of?
1.
That means there's a remainder of 1. If you don't know that, how could you figure it out? You could take 4 and times it by the 143. And when you do that, you're going to get 572. If I'm at 572 and I needed to be at 573, how many leftovers are there?
1.
So that means that 573 is really equivalent to I to the first. Does that make sense?
Yep.
Questions on that? So don't get scared. Those are really easy questions. If you understand it, they should be very easy. And I think legit, possibly on the darn SATs, you might see just this question. What is that equal to? That's 247. Try that on your own real quick. I 247. What is that equivalent to? I want it as I to what power, and then what's the other thing that that's equivalent to? Meaning I the first is equivalent to this, like finished. I want all I to what power. So you got to fill that in, and you got to fill in what's that equivalent to.
To the 3rd power.
Perfect. Robert, does that make sense?
Yeah, I was unsure if I was allowed to have I3 to the 3rd power. I mean, so
You
just
can
like,
have. You're allowed to have I to the first, I to the second, I to the third, or I to the 4th. By the way, if it's going to be equivalent to I to the 4th, how many remainders are there going to be?
0.
0, because that means, so you're going to get 0 remainders. That means that it's equal to, so like I to the 16th, that's really equivalent to I to the 4th, because 4 goes into it. There's going to be 0 remainder, which means it's equivalent to just a 1. Because I can write that as I to the 4th times I to the 4th times I to the 4th times I to the 4th. And that's like I to the 16th. So all those turn to 1, 1, 1, 1, and 1 times 1 times 1 times 1 is 1. So you can have any of these. It's just going to keep repeating over and over. All right, questions from homework. If you want answers from homework, I'll give you the answers. If you want me to go over it after you get that, whatever you need. This is your time for homework. Okay, Jonah.
Could you go over?
No, Jonah told me that he doesn't have a mic. So if you don't have a mic, Jonah, like raise your hand if I say your name or something, and then type it in the comments. I have to keep the participants open just in case someone decides to rejoin us. So just raise your hand, and then I'll look at it, and then I'll see that there's a comment up there. Go ahead, Ors, because you can still ask for questions.
Number
Go ahead,
33.
sorry. 33. Okay.
It's the 4 minus 4i over 1 plus 3i.
All right, so what's the issue? Stay unmuted, Ors. You and I are having a conversation. Whenever you ask a question, It's going to be you and I, and everybody else can kind of listen to us talk. But I want you, the questions I'm asking you are the question you should ask yourself to solve this problem. So what's the problem with this problem?
There's an I in the denominator.
Exactly. How do I get rid of it so that there's no I? What was that trick that I showed you so that the I's actually cancel out? It kind of, we talked about at the beginning of this class.
I multiplied both the top and bottom with 1 negative 3i.
Perfect. That's called its conjugate pair. So you're going to multiply it by its conjugate pair. Beautiful. Oh, yep,
so
sorry.
the
Yep,
top
no,
one
right.
is
You're right.
positive?
No.
Oh,
I messed up. Sorry.
okay.
Someone came in and I just stopped thinking for a second. Nope, you're right. So when I do this, Orest, I take care of the bottom because I don't like switching back and forth. It's too much for my brain to handle. And I said to some kids earlier today, I'm not trying to be mean. It's just a fact. I'm smarter than you guys. Now, that's because right now I've taken more school than you. But hopefully what happens is I lay a foundation and you go on to be way smarter than me. Like that's my dream as a teacher. That's my dream as my, for my kids. But this turns into, I'll do it real quick, Orest. This turns into this plus 1 minus 9i squared. This turns into a negative 1. So that turns into a 1 plus 9, which is a 10.
Yeah, I got there.
Then you distribute this top one. 4 times 1 is 4. This times this is a positive 12i. This times this is a negative 4i. This times this is a positive 12i squared.
Mm-hmm.
Okay, this turns into a negative 1. Did you do that?
I think so.
So
Yeah.
then that turns into, basically up top we have 4 minus 12, because that 1 times a positive 12 is a negative 12.
Wait. I got 4 minus 4i minus 12i plus 12i squared.
You got 4 minus 12? Yes, you should have. Minus 4i plus, yep, that's what it should be. You're right. So then the 4 minus 12 should be a negative 8.
Mm-hmm.
And then this together makes a negative 16i. And then what number goes into 8 that also goes into 16 that also goes into 10?
4 and 5.
2.
No.
2 goes in all of them.
2,
So it should be negative 4 minus 8i over 5. And another way of writing that is negative 4/5 minus 8i over 5. That could be another way that you write it. If you leave this, that's cool for me.
Okay.
All right?
Yeah, I got it.
That's it.
I just have a real quick question.
Yep, go ahead.
How would for 30 and 32 and 33 would you simplify that always?
For
If
30,
it has
13,
if it has because you could go by 9 for the top numbers in 32.
tell
would
me
you
what it was. Tell me what was you got to the final answer. What was it?
I got 36 minus 18i over 9.
So because all 3 of these share something, you can get rid of it in all 3 of them.
Okay.
So like you said, 9 goes into all of them. But let's say I end up with like 10 plus 3i over 5. Sometimes they might say, hey, 10 over 5 plus 3i over 5. And you can simplify this one so it would turn into 2 plus 3i over 5, because you cannot see right here, 5 goes into 5, 5 goes into 10, but 5 doesn't go into that. So you can't simplify all 3 together. Whereas this one, 9 goes into there, 9 goes into there, 9 goes into there, so you can simplify all 3 of them at one time.
Okay, I just didn't know if I was supposed to simplify. Thank you.
Yep. All right.
Have a good day.
Thank you guys. Have a good weekend. You will have homework. Thank you guys staying. I know it's a little late.
Where do we find the homework? Like when you put it out?
Hold on 1 second. So you go on Portal? Who asked that?
Robert.
Hey, Robert, so you go, do you know how to use Portal?
Yeah,
So-
because I did
so-
the 2.4 part 1 and 2. Although the answers may not be completely correct because
That's okay. It's I just do effort and trying, but that's why. So when I go over homework, I'll try to give you more time. Or like Monday, if I don't, you can be like, hey, Mr. Martin, can you go over this one? I'll go back and go over anything that you have questions on.
Okay, so you'll be posting the homework for us this weekend?
Yes, it's not there yet because I don't have a planning period until 7th period.
Okay, thank you. I just didn't know.
Yeah, it will be there. If it's not there before